Hello everyone, today I'm going to show how you can make a lithium-ion battery charger quickly or to buy a suitable charger from Amazon or other places. Some time back, a friend of mine told me that he lost his charger for his newly bought flash lamp like this one, and it has a lithium-ion battery like this one. So he told me that, is there any other way that he can charge this kind of batteries? I told him yes, and I bought a small circuit board to charge this battery and from Amazon, and this is the circuit board which can charge lithium-ion batteries, and these are not so expensive, only $10. And I also made a battery charger on my own and using a very small IC. You can see this is the commercially available IC. So the charger circuit is actually very small here, you can see. And today I'll also show how you can make a battery simulator, which I have it in my hand. So this simulator can quickly check the performance of a charger. I'm going to tell very briefly how a lithium-ion battery works, its advantages, how to charge a lithium-ion battery. I'll also show how to make a battery simulator to quickly check the performance of a battery charger. I'll compare the performance of two chargers, one that I built using a microchip IC with the other one that I bought from Amazon. A lithium-ion battery or any other battery basically converts electrical energy into chemical energy and stores it. During the discharge process, this stored energy is converted back into electrical energy. Previously, rechargeable battery market was ruled by lead acid battery, nickel metal hydride battery, and nickel cadmium batteries. However, lithium-ion batteries are now quickly replacing all these batteries due to several advantages. Number one is energy density is very high. A small volume, it can store a lot of energy. Number two, charge discharge cycle 400 to 1200 cycles before it dies. Terminal voltage is 3.7 volt, and microcontrollers and other digital ICs are available to operate at 3.3 volts. So a single battery can run those. White LED is replacing the conventional lighting system now. So white LED threshold voltage is 2.5 volt. Ordinary dry cell or nickel metal hydride battery is unable to drive a white LED, but a lithium-ion battery can easily drive. There are several types of rechargeable lithium-ion batteries. The basic construction is like this. Two electrodes are immersed in an electrolyte. One of the electrode is lithium cobalt oxide and the other one is graphite. The electrolyte is a kind of lithium salt solution, and there is a separator in between these two electrodes. Whenever a charging supply is connected to a lithium-ion battery, lithium-ion starts moving from lithium cobalt oxide electrode to the graphite electrode, and ions are deposited on the graphite. We call the battery is charging. What happens to a discharging process? If a load is connected to the battery now, a fully charged battery, stored lithium ions move from anode to cathode through the separator. This is a kind of most widely used lithium-ion battery. It is commonly called 18650 battery. This name came from its size, 18 mm diameter and 65 mm long. When a battery is fully charged, its nominal voltage is around 3.7 volt. When a load is connected, its stored energy is being drained and its terminal voltage starts to go down. A fully discharged battery gives 3.3 volt at the terminal. However, whenever it reaches 3.5 volt, we can consider it to be discharged battery. When connected to a source and starts to charge at full charge with the supply connected, we get 4.2 volt. A lithium-ion battery life and safety depends upon the charging process. For safe charging, initially, the charging supply should act like a constant current source. As the battery is being charged, terminal voltage increases slowly, and when it reaches 4.2 volt, the charging should switch from constant current to constant voltage source. At this voltage of 4.2 volt, charging becomes slower and charging current slowly decreases and almost to few milliampere, and then we can say the battery is fully charged. As the charging process is slow, to assess the performance of a charger, we can use a battery simulator. Here, I am showing how one such simulator can be made. I took a logic level MOSFET, 2 fixed resistors, and 1 variable resistor. This kind of circuit behaves like a power Zener diode with a variable Zener voltage. If I connect such a circuit with a charging supply, with an ammeter and a voltmeter as shown, by varying the variable resistor, we can control the terminal voltage. Thereby recording the voltage and current, we can determine the performance of the charger. This slide shows the characteristics of the battery simulator. As the variable resistor values goes lower, the knee voltage goes higher. This adjustable behavior of the knee voltage gives us the opportunity to measure the performance of a charger. This is the practical circuit that I built, the MOSFET, the variable resistor and the fixed resistors. First, I'll show the performance of the charger that I built using commercially available IC. It is a microchip IC, part number MCP73812. I choose the package called SOT23. Only 2 additional capacitors and 1 resistor is needed. Input voltage is 5 volt and maximum charging current is 500 milliampere. Any USB port or 5 volt supply can be used to charge the battery using this circuit. After building the charger, it was first connected with the battery simulator as shown here. A fully discharged lithium-ion battery whose terminal voltage was 3.2 volt is connected. Initially at 3.2 volt, the charging current is 370 milliampere. When the terminal voltage is 4 volt, current becomes 500 milliampere. This is the maximum one. From this point, current starts to go down. This is the photo of the experimental setup. The fully discharged lithium-ion battery, the charger, current meter and voltmeter, and this is the 5-volt supply. Charging characteristics with time is shown here. When the battery voltage is low, charging current is 500 milliampere. As the voltage goes up and the current goes down, it took nearly 2 hours to fully charge the battery, which has the capacity of 3800 milliampere hour. Higher capacity battery will take longer time to charge. This is the charger that I bought from Amazon. For the price of 15 Canadian dollar, you can get 5 of this charger with 5 battery holders. The board that I bought from Amazon is not only a charger. This board also has a DC to DC converter, which converts from 3.7 volt to 5 volt. This is the schematic diagram. The IC it uses is manufactured by an Asian country and not available in North America. Like the previous case, this charger was also connected to the battery simulator and tested first. The maximum charging current is 1 ampere when the terminal voltage is below 3.7 volt. As the voltage increases to 4 volt, current drops to nearly 800 milliampere, and close to 4.2 volt, the current is almost zero. This is the photo of the experiment. The charger, a discharged lithium-ion battery, 2 meters to measure voltage and current, and the power supply. This slide shows the charging characteristics of the charger. As the battery is not fully discharged, voltage starts with 4.1 volt. At this voltage, the current is around 400 milliampere. As the voltage goes up, charging current goes down. It took nearly 2 hours to fully charge the battery. As mentioned earlier, that the Amazon charger also includes a DC to DC converter. It accepts 3.7 volt lithium-ion battery, and at the output it gives plus 5 volt, a regulated output. This plus 5 volt can be used to charge a cell phone or can power any USB compatible device. This is the most widely used size of lithium-ion battery. It is called 18650. I am measuring the terminal voltage. It is a fully discharged battery, and it shows that it is nearly 3 volt. This is the charger that I built using a microchip IC and 3 more components. This is the charger that I bought from Amazon. This is the battery simulator that I built to test the performance of the chargers, the variable resistor, 2 fixed resistors, and the MOSFET. This is the lithium-ion battery. I am going to test the performance of the charger that I built using the microchip IC. I am connecting the charger with the battery simulator. 2 meters are used. One is for measuring the current and other one for voltage. I am now adjusting the voltage, terminal voltage. Now you can see that the terminal voltage is 3.9 volt. The volt is shown on the left side of the meter and the right side shows the current, and current is 500 milliampere. Now the terminal voltage increased to 4.1, the current is still 500 milliamps. So terminal voltage is now 4.18 and the current you can see 140 milliamp. At around 4.2 volt, the current is almost zero. The charger is connected to the battery. As you can see, the voltage is 3.8 volt and the charging current is 0.48 amp or 480 milliamp. As time goes on, the battery is being charged. The voltage will go up and the current will go down. But now it is in constant current mode, so terminal voltage is 3.86 and current remains constant at 480 milliamp. After some time, the terminal voltage becomes 4.18 volt and the current goes down further when the terminal voltage is 4.2 volt. Now the Amazon charger is connected to the lithium-ion battery. The same battery is used. After discharging, the voltage, you can see the supply voltage is 5 volt. Here is the terminal voltage. It is almost close to 4 volt. And the charging current initially is 720 milliampere. So quickly the terminal voltage is going up. Now it is 4 volt and charging current is going down, you can see. As the charging current goes down, terminal voltage goes up. When fully charged, current goes almost to few milliampere and terminal voltage would be 4.2 volt.